The map of our world is about to change. I'm talking about the continent of Africa splitting into two.
A massive geological transformation is unfolding beneath the eastern region of Africa, one that has the potential to reshape the very structure of the continent itself. In the vast, rugged landscapes of East Africa, scientists have observed the Earth cracking apart, a phenomenon known as continental rifting. This isn't simply a few superficial surface fractures. What's happening is a deep and powerful tectonic event that over millions of years could divide Africa into two separate land masses. The implications of this monumental geological process are vast, extending beyond geography to include climate, ecosystems, economies, and even the daily lives of people in the affected regions. Before we start, smash the like and subscribe buttons for more updates. The East African Rift System, where this split is most prominently occurring, stretches thousands of kilometers from the Afar Triple Junction in northeastern Ethiopia down through Mozambique. It is one of the most significant and active continental rift zones in the world. Unlike other tectonic processes that are mostly invisible or only noticed through sporadic earthquakes, the East African Rift offers a rare glimpse into the slow but relentless tearing apart of a continent. The landscape here bears dramatic evidence of what's happening deep underground. Gaping fissures in the earth, volcanic activity, new valleys forming, and the slow drift of tectonic plates moving in opposite directions. At the heart of this phenomenon is the movement of tectonic plates, the massive slabs of rock that make up Earth's outer shell. The African plate is splitting into two major parts: the Nubian plate, which comprises most of Africa, and the Somali plate, which includes the eastern portion of the continent. These two plates are gradually drifting apart, pulled by geological forces from beneath the surface. This is not a sudden or violent event in human terms. The rifting is occurring at a pace of a few millimeters to a few centimeters per year, but in geological terms, that's a sprint. Over the course of tens of millions of years, that rate of separation could result in the complete division of the African continent, creating a new ocean basin between the two land masses. One of the most extraordinary aspects of this tectonic activity is that it is creating a brand new ocean. As the plates continue to drift apart, magma from beneath Earth's crust rises to the surface to fill the gap. This molten rock cools and solidifies, gradually forming new crust. The process is essentially identical to what happens at mid-ocean ridges when new seafloor is created. Eventually, water from the surrounding seas, likely from the Red Sea and the Gulf of Aden, will flood in, transforming the Rift Valley into a narrow ocean that will expand over time. In geological time frames, it is not far-fetched to say that a new ocean will one day flow where the East African Rift now lies. Regions most affected by this tectonic activity include Ethiopia, Kenya, Tanzania, and Mozambique. In Ethiopia, the Afar region is particularly significant. This desolate, sun-baked landscape is situated at the juncture of three diverging tectonic plates: the Nubian, Somali, and Arabian plates. The Triple Junction is one of the most geologically active areas on the planet. In this area, massive fissures have been observed forming in the earth, some measuring dozens of kilometers in length and several meters wide. In 2005, a crack over 60 kilometers long opened up in just a few days in Ethiopia's Afar Desert, an event that captured international attention and gave scientists a vivid demonstration of the immense forces at play. This tectonic divergence isn't just shaping landforms. It's profoundly affecting volcanic activity as well. As the crust stretches and thins, magma is able to rise more easily to the surface, fueling frequent volcanic eruptions in the region. The East African Rift is dotted with volcanoes, many of which are still active. Mount Nyiragongo in the Democratic Republic of Congo and Mount Old Doinyo Lungai in Tanzania are notable examples. These volcanoes not only remind local populations of the power simmering beneath their feet, but they also represent key indicators of the rifting process. Each eruption contributes to the geological reshaping of the land, adding new rock and altering the surrounding environment. This splitting of Africa holds profound implications for the continent's geography. Over millions of years, the formation of a new ocean will result in the reconfiguration of national borders, coastlines, and possibly even entire ecosystems. The land to the east of the rift, comprising parts of Ethiopia, Kenya, Somalia, and Tanzania, will eventually become a large island, akin to how Madagascar split from India and Africa millions of years ago. The idea of an entirely new land mass emerging is not just a curiosity for geologists, but a glimpse into Earth's long-term future. It's a vivid example of the planet's capacity for renewal and transformation, constantly reshaping itself in ways that are hard to fathom in a human lifetime. The ecological consequences of the rifting are equally fascinating. As the land splits and new valleys and highlands form, habitats are disrupted and new ones created. Lakes can form in the rift valleys as water collects in the low-lying areas, altering the local hydrology and influencing both plant and animal life. The East African Rift Valley is already known for its biodiversity, supporting unique ecosystems that are home to species found nowhere else on Earth. As the land continues to change, so too will these ecosystems. Some species may thrive in the new environments, while others may face extinction if they cannot adapt to the new conditions. This ongoing transformation creates a living laboratory for evolutionary biologists and ecologists who study how life responds to rapid environmental change. Human life in the region is already closely intertwined with the land, and the rifting has direct and indirect effects on the people who live there. Earthquakes and volcanic eruptions pose real risks to communities situated near active rift zones. Infrastructure such as roads, buildings, and pipelines can be damaged or rendered unstable by ground movement. Additionally, the shifting land can disrupt agriculture and access to fresh water, particularly in areas where fishes open up unexpectedly. These challenges require adaptive planning and investment in resilient infrastructure to ensure that communities can continue to thrive despite the geological instability. The economic implications are just as significant. As rifting progresses, new mineral resources may become accessible, offering opportunities for development and investment. Rift zones are often rich in geothermal energy due to the heat emanating from the thinning crust. Countries like Kenya have already begun harnessing this potential, tapping into geothermal power to meet their growing energy needs. As the rifting continues, geothermal energy could become a major source of sustainable power for the region, reducing dependence on fossil fuels and contributing to climate resilience. Moreover, as rift valleys widen and potentially fill with seawater, new transportation routes may open. A newly formed seaway, for example, could dramatically alter trade patterns across the continent. Ports may shift from interior lakes to new coastal locations, and the strategic importance of certain cities could change based on their proximity to the emerging ocean. While these changes are far in the future, understanding the long-term implications can help guide investment in infrastructure and regional planning. Scientists are watching this event closely, not only because of its uniqueness, but because it offers a real-time model for how continental rifting leads to the formation of new ocean basins. The data gathered from the East African Rift is crucial for refining theories of plate tectonics and understanding Earth's geological history. It provides insight into how ancient supercontinents like Pangaea once broke apart, setting the stage for the continents we know today. In that sense, what is happening in East Africa is both a continuation of Earth's long story and the beginning of a new chapter. Beyond the scientific fascination, the rifting is a stark reminder of the dynamic nature of our planet. Earth is not static. It is alive with motion, constantly reshaping its surface through immense tectonic forces. While these changes often happen on time scales that seem distant and abstract, their consequences are very real, especially for the communities living on the front lines of geological activity. The rifting of Africa is not an isolated event, but part of a broader narrative of Earth's evolution. A narrative that includes the rise and fall of continents, the birth of oceans, and the continuous reorganization of the planet's surface. As the rifting continues, attention must also turn towards sustainable coexistence with this dynamic process. Urban planners, policymakers, and scientists will need to collaborate to ensure that communities in the affected areas are equipped to deal with the challenges posed by the geological changes. This includes designing buildings that can withstand seismic activity, developing early warning systems for volcanic eruptions, and educating the public about the risks and realities of living in an active rift zone. In many ways, The rift is not just shaping the land, but also prompting a rethinking of how humanity interacts with Earth's natural processes. The East African Rift also serves as a symbol of natural forces that often go unnoticed in the course of daily life. Beneath the soil, beyond the quiet landscapes, a grand transformation is in motion. It challenges perceptions of permanence and reminds us that continents, which seem so vast and immovable, are in fact fluid dynamic systems subject to the same laws of physics and motion that govern the rest of the universe. While the eventual division of Africa into two continents may take tens of millions of years, the early signs are here and now. Scientists can see the initial stages, measure the motion, and predict the potential outcomes with increasing precision. This moment in Earth's history is unique because it is happening during a time when humans are not only present but capable of observing and understanding it. It's a rare intersection of geological time and human awareness, a slow-motion transformation that offers both wonder and warning. In essence, the splitting of Africa is not just about tectonic plates drifting apart. It's a story about change on a grand scale, a natural event that transcends human timelines yet affects human lives. It is a demonstration of the planet's inherent dynamism and a glimpse into its future shape. The land is moving, the earth is cracking, and a new world is quietly taking form beneath the feet of those who call East Africa home. The unfolding of this geological drama is one of the most fascinating and important events on the planet today. As the rift deepens and spreads, it carries with it the weight of transformation, not just of land, but of life, ecosystems, nations, and the very notion of what a continent is. As the tectonic plates beneath Africa continue their slow divergence, the true scale of the transformation becomes clearer with every scientific expedition, satellite scan, and geological survey. This is not merely a regional occurrence. It's a planetary phenomenon that speaks to Earth's perpetual cycle of formation and division. With each millimeter of movement, the continent edges closer to a dramatic reconfiguration of its geography, triggering a cascade of changes across its environments, resources, and human societies. What makes this event so profound is not only its eventual consequence, but the intricate and varied ways it affects the natural world and human systems in real time. One of the most compelling facets of the African continental rift lies in its role as a cradle for geological innovation. As the land stretches and fractures, entirely new terrains are emerging. Basins are forming where there were once uplands, and highlands are rising from flatlands. The creation of escarpments, steep cliffs formed from the downward shifting of land blocks, introduces new geographical barriers that influence weather patterns and determine water flow. Rain that once collected in large plains now finds itself diverted into valleys or trapped in newly forming basins. This redirection of hydrology redefines ecosystems in profound ways as aquatic systems shift and flora and fauna must adapt to new realities of access and scarcity. Rainfall distribution, for instance, can be significantly altered by changes in topography. In high-altitude regions, newly formed by tectonic uplift, orographic rainfall becomes more prevalent. Moist air pushed upwards by mountain slopes cools and condenses into precipitation. These changes result in microclimates forming across the Rift Valley, creating localized zones of increased rainfall and humidity. As a result, pockets of unexpected fertility can appear, fostering unique agricultural opportunities or challenges depending on how these new environments interact with traditional land uses and settlement patterns. Equally transformative is the impact of rifting on freshwater availability. Groundwater systems, aquifers, and river networks are disrupted as the crustal blocks separate and tilt. Water can become more difficult to access in some places, especially where aquifers drain into newly formed valleys or fissures. Bridges may have to span growing gaps, and energy grids must allow for rerouting around volatile areas. These challenges also present opportunities for innovation in civil engineering and architecture as designers respond to the unique demands of a shifting continental base. One of the more unexpected yet deeply influential effects of rifting lies in its potential to reshape cultural identities. Throughout history, geography has played a foundational role in the development of cultures, languages, and traditions. Mountains isolate communities. Rivers provide lifelines, and fertile valleys give rise to unique agricultural practices. As the African continent reshapes itself, so too might the cultural boundaries of its people. The slow birth of a new sea, for example, could isolate populations, leading to linguistic divergence or new ethnic configurations. Conversely, tectonic processes that bring new resources or unify regions through shared challenges might foster cooperation and cultural blending. Climate dynamics are another domain where rifting plays a catalytic role. As land masses shift and oceans form, they alter global wind and ocean circulation patterns. In the longer term, the formation of a new ocean in East Africa would introduce a major source of evaporation and heat exchange into the global climate system. Ocean currents would eventually adjust to the presence of this new body of water, potentially influencing weather far beyond the African continent. While such effects may lie millions of years ahead, even the present changes in topography can create subtle shifts in regional climate affecting rainfall distribution, vegetation patterns, and agricultural productivity. In the realm of biology, the rifting process serves as a powerful agent of speciation. Geographic isolation caused by rifting can create evolutionary pressure, leading to the divergence of species over time. The African Great Lakes, many of which lie within or near the rift, are already some of the most biodiverse freshwater ecosystems in the world, home to hundreds of endemic fish species. As rifting continues and new lakes and river systems form, more opportunities for evolutionary experimentation will arise. These environments will act as natural laboratories, offering scientists insights into how species adapt to rapid geological change. Endemic species, those that exist nowhere else, will likely continue to emerge, each one a living testament to the continent's shifting identity. Rifting also introduces new microbial environments as subterranean ecosystems are exposed. Volcanic vents and geothermal springs bring mineral-rich fluids from the deep earth to the surface. These environments are often extreme, highly acidic, hot, and rich in metals, but are home to specialized microbial life. The organisms that thrive here are of great interest to biologists, especially those studying the origins of life or developing biotechnologies. Extremophiles, organisms adapted to harsh conditions, have potential applications in medicine, industry, and environmental remediation. As the East African Rift continues to evolve, it may well prove to be a frontier not only for geology and ecology, but also for biotechnology. Meanwhile, the psychological and cultural perception of the rift cannot be ignored. For communities living along the rift, the visible scars on the land and the felt tremors beneath their feet are daily reminders of nature's power. In some cases, these phenomena are woven into local lore, spiritual beliefs, and traditional knowledge systems. The appearance of fishes, the sudden creation of a lake, or the eruption of a long-dormant volcano often takes on spiritual significance. In the coming years, it will be important for scientific engagement to respect and incorporate local understandings of the land. Collaborative approaches that bring together modern science and indigenous knowledge will offer more holistic and effective responses to the challenges posed by the rift. Education and public awareness will also play a vital role in navigating the future of a rifting Africa. As geological change progresses, it is essential that people understand what is happening and why. Geoscience curricula in schools, public outreach through media, and community-based workshops can help demystify the process. Knowledge empowers communities to better prepare for natural hazards, advocate for resilient infrastructure, and make informed decisions about land use and resource management. The story of the rift is not only a scientific narrative, but a human one, and it must be told in languages and formats that are accessible to all. In a broader planetary context, what's happening in Africa is a reminder that Earth is not finished. While the continents may appear fixed and permanent, they are in constant motion, governed by the churning of molten rock beneath the crust. The process now seen in East Africa is similar to what separated South America from Africa or what opened the Atlantic Ocean. Witnessing the early stages of continental separation offers a rare and invaluable opportunity to study the mechanics of planetary evolution as they occur. This is the kind of event usually understood only through ancient rock records. Yet here it's happening in real time. The East African Rift is also a natural point of comparison for understanding other planetary bodies. Mars, for example, bears massive rift systems like Valles Marineris, which dwarf those on Earth in scale. Studying rifting on Earth helps scientists interpret planetary geology elsewhere in the solar system. The insights gained here could one day inform missions to other planets and moons where tectonic activity or the absence of it holds clues to geological history and potential habitability. Looking ahead, technological advances will further enhance our ability to monitor and respond to the rift's progression. Satellite imaging, seismic sensors, GPS arrays, and remote sensing drones are becoming more accurate and more widely deployed. These tools allow scientists to map the smallest movements of the Earth's crust and identify patterns that signal increased volcanic or seismic risk. The integration of artificial intelligence into these monitoring systems could revolutionize early warning protocols, giving communities valuable time to prepare for geohazards. What lies at the center of all these changes is a fundamental truth about the Earth. It is alive. It breathes, shifts, grows, and renews itself in cycles of transformation that span millions of years. The African continent's slow division is not a catastrophe to be feared, but a natural evolution to be understood. It is a reminder of our place in a world that is both ancient and ever-changing. The rift is not merely a line on a map or a crack in the ground. It is a doorway into Earth's deeper workings, a dynamic expression of the forces that shape continents and civilizations alike. As new seas rise and mountains fall, as ecosystems shift and cultures adapt, the story of Africa's splitting will continue to unfold over millennia. It will touch everything from the shape of the land to the identity of its people. It will be written in the fossils of species that have yet to evolve, the maps of future explorers, and the legends of generations not yet born. This is not just a geological event. It is a symphony of movement, pressure, life, and time, conducted by the unseen hand of Earth's inner fire. The rift is not simply tearing Africa apart. It is creating the future,